Now, what we're going to be working with today is binomial expansions, but we're also going to learn about variance, which you were asked to find in the pre-assessment yesterday, and standard deviation. Those have to do with kind of statistics. Binomial expansion is actually very similar to some stuff we've seen before. What does the word binomial mean? Two. So that means that we have a set of parentheses with two things in it. So something like x plus 3. Is that a binomial? Yes, there's two things inside of it. Okay? So we're going to first expand some binomials and look for patterns. If I have a plus b to the first power, does that change anything? No. So this is going to be the same as 1a plus 1b, right? And typically we don't write the 1 in front. For right now, so that we can see the pattern, I want you to. Okay? So typically we don't write the 1 in front, but in order to see the pattern. So what about a plus b squared? What am I going to do there? Can I just distribute that exponent in? No. What do I have to do? A plus b squared is the same as a plus b times a plus b. So let's do it. You can use the boxes or you can use FOIL, whichever one you prefer. I like FOIL, so a times a gives me a squared. A times b gives me plus, this is 1a squared plus 1ab. B times a plus 1ab. And b times b plus 1b squared. Then what can I do? Combine like terms. 1ab plus 1ab gives me 2ab. So this is 1a squared plus 2ab plus 1b squared, right? Okay, so let's fill that in here. So that was 1a squared plus 2ab plus 1b squared. Okay. Now I want to know what is a plus b to the third. I already know a plus b to the third is a plus b times a plus b times a plus b, right? Do I already know what this part is? We already did it, right? So this is the same as a plus b times 1a squared plus 2ab plus 1b squared. You guys okay with that so far? Okay, so then we can FOIL again or use the boxes if you want to. Let's use the box this time. Who said yes? Yes. Okay, so we have, let's do 3 and 2. So that's a squared plus 2ab, or 1a squared, plus 1b squared. 1a plus 1b. Okay. A times 1a squared. 1a to the third. A times 2ab. 2a squared b. A times 1b squared. ab squared. 1ab squared, right? Okay. B times a squared. 1 a squared b. B times 2ab. That's 2ab squared. And b times b squared. B to the third. So that's 1. Okay, let's combine our like terms. I have a to the third, which doesn't have any like terms. So that's 1a to the third. I have 1a squared b plus 2a squared b. What's that give me? 3a squared b. 2ab squared plus 1ab squared? 3ab squared. Plus 1b to the third. Okay, so let's fill that in. So that is 1a to the third plus 3a a squared b plus 3ab squared plus 1b to the third. Do you guys see any patterns so far?
Yes.
What?
You're just adding the first one to the second. The second is just like
We're just adding them together, right? What's 1 plus 1?
2.
2. What is 2 plus 1?
3.
3. And 2 plus 1?
3.
3. 2 plus 1 again. Okay, so what do you think a plus b to the fourth is? What I want you to do, multiply it all out, use the boxes or foil, and fill out the blanks, but then see if it matches up with your hypothesis. So a plus b to the fourth, that's a plus b times itself how many times?
4 times.
4 times, right? Which is the same as, everybody agree, a plus b times a plus b times a plus b.
Just do number 2 twice.
You could do number 2 twice. We could also do number 3, right? This is a to the third times a plus b, right? Yeah? Okay, so that's what I'm going to do. So we got a to the third as, so this is a plus b. I'm going to do FOIL this time. A to the third plus 3a squared b plus 3ab squared plus 1 plus b to the third. Okay, so this is a to the third. That's this part. This is the third one, right? And to get it to the fourth, we're multiplying times a plus b once more. Yes, right? You guys okay with that? Okay, so when we FOIL it out, you don't understand what? Okay. So I'm going to use FOIL. A times a to the third gives me a to the fourth. A times 3a squared b gives me plus a to the 3a, oh my goodness, plus 3a to the third b plus a times 3ab squared, 3a squared, b squared, plus a times b to the third, ab cubed. So far so good? Okay, now we do multiply everything by b. A to the third plus b. That's a to the third b. B times 3a squared b, that's plus 3a squared b squared. I'm going to run out of room. B times 3ab squared, 3a b to the third, and b times b to the third, b to the fourth. Okay, let's combine like terms. Okay, how many a to the third b's do you see? Here's an a to the third b, here's an a to the third b, right? So that's going to be 1a to the fourth plus 3a to the third times b plus 1a to the third times b? 4. A to the third b. Okay, let's go to the next one. 3a squared b squared. Do you see any more a squared b squareds? That one, what does that give me? 6a squared b squared. And then ab to the third, and do you see any more ab to the thirds? There's a 3ab to the third. So what does that give me? 1ab to the third plus 3ab to the third. 4ab to the third. Plus whatever was left over, b to the fourth. Did you guys fill that in? Okay, let's fill it in. This is a lot of work, right? There's a trick. Okay, so this would be 1a to the fourth plus 4a to the third b plus 6a squared b squared plus 4ab to the third plus 1b to the fourth. Did our coefficients follow the pattern?
Yeah.
Yeah. 1 plus 3 gives me, guys, what's 1 plus 3? 4. 3 plus 3 gives me 6. And 3 plus 1 gives me 4. And I always have 1s on the ends, right? Okay, what about the exponents? Do you guys notice a pattern about the exponents? Yeah, we add 1 every single time to the exponent. So, and it starts with the power that we're trying to find, right? So our exponent is 4. So we start with the first term, which is a, and we raise that to the 4th. B would be to the what? 0, right? A to the 4th is the same, does everybody agree, as a to the 4th, b to the 0? What's b to the 0? 1. So that's a to the 4th times 1. It's not really there, right? Exactly. That's exactly what we're doing. So we start with a to the 4th, b to the 0. Our next one is we lose 1, a to the 3rd, but b gets raised to the 1st. Then I have a to the 2nd, b to the 2nd. A gets 1 less, a to the 1st, b to the 3rd. So we are, from the first term, we're subtracting each time, 1 each time, and from the second term, we're adding 1 each time. They should always, your exponent should always add up to the exponent that you're trying to find. Think about it. 4 plus 0 gives me 4. 3 plus 1 gives me 4. 2 plus 2 gives me 4. 1 plus 3 gives me 4. And 4 plus 0, 4. Does that make sense? Kind of? Will you guys try doing a plus b to the 5th using the pattern? Don't try doing all the work, just try using the pattern. Becca, do you want to read me what you got? 1 a to the 5th, yes. 5 a to the 4th b. 10 a to the 3rd b to the 2nd. 10 a to the 2nd b to the 3rd. A b to the 4th. 1 b to the 5th. Good, that's right. Got that. Some of you who... Okay, so how did you find, somebody that got it correct, how did you find the coefficients, the numbers in front of the A's and B's? Yeah, right, which we get by adding each of the coefficients from before. 1 plus 4 gives me 5. 4 plus 6 gives me 10. 6 plus 4 gives me 10. 4 plus 1 gives me 5. And our outsides are always 1. How about my exponents? Can someone explain to me how I got my exponent? Yeah, we add 1, we subtract 1 from the first term each time, and we add 1 to the second one each time, right? Okay, so what would a plus b to the 6th be? Figure that one out really, really quick. Okay, Alyssa, what'd you get? 1a to the 6th, 6a to the 5th, b. 15a to the 4th, b to the 2nd. So a decreased by 1 and b increased by 1. 20a to the 3rd, b to the 3rd. 15a to the 2nd, b to the 4th. 6a b to the 5th. And 1b to the 6th. Yes?
Yeah.
Got it? Okay, we have what is called Pascal's triangle. Pascal is a mathematician from France. Yes, France, and he discovered that when you expand binomials, we follow a pattern every single time for the coefficients. Okay, so we can follow Pascal's triangle every single time to get the coefficients. When we have no terms at all, the answer is always going to be 1, right? So we actually start a plus b to the first power. Our coefficients are 2 1s, correct? So that's actually the second step of the pyramid. So this would be at n equals 1, this one. The n is your exponent. Okay, so when my exponent, n, is 2, my coefficients follow the pattern 1, 2, 1. Is that what they did? 1, 2, 1. What about when my exponent was 3? 1, 3, 3, 1. Is that what we got? 1, 3, 3, 1. What about 4? 1, 4, 6, 4, 1. And that's what we got, right? So we can use Pascal's triangle as a shortcut to figure out what our coefficients are going to be before we actually write it all out. You can make the triangle yourself even if it's not given to you. We start with 1, 1, and 1, and then we just add every single time to get the next term. 1 plus 1 gives me 2. We start with 1 on the side. 1 plus 2 gives me 3. 2 plus 1 gives me 3. End with 1. 1 plus 3 gives me 4. 3 plus 3 gives me 6. You can make it yourselves. Yes. Okay, so let's do it with some examples. Example 1. X plus 3 to the 5th. So which row of Pascal's triangle am I going to use? The 6th. It's actually technically the 6th row, right? But we look for where the outside term is 5. That'll give us a hint. Okay, so what are my exponents going to be? Okay, this is our A term, this is our B term, so we actually have a number in place of B this time. But that's going to be 1 x to the 5th plus 5, the next term is 5, x to the 4th. What's B?
3.
Times 3 to the 1st power, right?
Yeah.
Plus, yeah. Plus the coefficient's going to be the problem. It's not always going to be exponents. Sometimes there's going to be numbers in there. So plus 10 x to the, what's 1 less than 4? 3 times 3 to the 2nd power. Plus your next coefficient is 10. What's 1 less than 3 for x? 3 to the, if we had 3 to the 3rd, so it's going to be x to the, 2nd, times 3 to the, 1 more than 2 is 3, plus 5, x to the what? 1st, 3 times 3 to the 4th, and then finally we end up at 1 times 1, or plus 1 times 3 to the 5th. And now we have to simplify. Oh my gosh.
When we simplify the 3, so we multiply it by the...
Yeah, when you simplify the 3's, we're actually going to end up multiplying it by the coefficient. Let's just simplify the 3's first, and then we'll simplify everything in a third step. Okay, so 1x to the 5th, we can leave that as it is, plus 5x to the 4th times 3 to the 1st, which is just 3, so I'm going to leave it this way for one more step, plus 10x to the 3rd times, what's 3 squared? 9. Plus 10x squared times 3 to the 3rd? 27. Plus 5x times 3 to the 4th? 81. Plus 1 times, what's 3 to the 5th? Who figured that out? 243. Good. Now we can actually multiply the coefficients and the numbers. So let's simplify it one last time. Give yourself some room because we're going to box our answer. 1x to the 5th. Can I just rewrite that as x to the 5th now? Okay. Plus 5x to the 4th times 3. What does that give me? 15 x to the 4th. Plus 10 times 9? 90 x to the 3rd. Plus 10 times 27? 270 x squared. Plus 5x times 81? 405 x. Oh, 270, thank you. Plus 1 times 243? 243. Done. And that's your answer. We expanded it all the way. See how the Pascal's triangle helps you a lot to find out your coefficients? We're going to skip to example 3. So this time the A term has a number in front of it, but that's okay. We're still going to do it exactly the same. We're just going to put it in parentheses each time until we start. We want to find the expansion to the 4th power. So which row of Pascal's triangle am I going to use? The 5th one, which has the 4 in it, right? When my exponent is 4. So my coefficients are going to be 1, 4, 6, 4, 1. Okay? Okay. So, let's start by just plugging everything in. My coefficient for the first going to be 1 times my A term, but my A term is 2p. So I have to plug in 2p. And I want to put it in parentheses. To the what power?
4.
To the 4th power. Good. Plus. What's the next coefficient? 4. 2p in parentheses. To the, what's 1 less than 4? 3rd. And negative q. There's a negative attached to my q, so I have to attach it to q and keep it with it the whole time. So that's going to be times negative q to the 1st power, right? Plus, in Pascal's triangle, the next coefficient is what? 1, 4, 6. So plus 6. My A term, which is 2p, to the what power? To the 2nd, times negative q to the 2nd. Raise the 1 to, add 1 to that exponent. Plus, the next coefficient is 4 times 2p to the 1st, times negative q to the 3rd, plus last one, negative q to the 4th. Okay, you guys with me so far? Okay, we just put, even if there's something, it's not a variable by itself, put it all in parentheses, we'll simplify it all out. Okay, so 1, 2p to the 4th. Okay, everything is being multiplied here, so I can distribute that exponent. So it's going to be 1 times, what's 2 to the 4th? 16, p to the 4th, plus 4 times 2 to the 3rd is 8, p to the 3rd, right? Times negative q. Plus 6 times 2 to the 2nd is 4 p to the 2nd times, what's negative q squared? Positive q squared, right? Negative q times negative q?
No, all together.
What?
You're making it other stuff.
Because we have a negative q to the 1st times negative q to the 1st. A negative times a negative gives me positive, so that q becomes positive, but 1 plus 1 gives me 2.
Is the negative q going to make them all negative?
No, just some of them. Okay, so that's 4 times 2p. Negative q to the 3rd, what's that going to give me? Negative q to the 3rd power. Plus negative q, all of that to the 4th, what's that?
Positive q to the 4th.
Positive q to the 4th. So the exponent doesn't go away, okay? Just the sign changes. Okay, let's simplify it all really, really quick. 1 times 16p to the 4th gives me 16p to the 4th. Plus 4 times 8 gives me what? 32 times a negative.
It's a negative 34.
So it's going to be minus 32 p to the 3rd q Okay, 6 times 4, what does that give me?
24.
24 times a positive q squared, so that's going to be plus 24 p squared q squared. 4 times 2? 8 times the negative q? Negative 8 p q to the third plus q to the fourth. Take your time, write out all the steps. We will go over some more tomorrow. You do have 2 homework assignments, so make sure you are aware of that.